what do doors, balloons, apples, paper clips, and a whale all have in common? They're all matter. But what is matter? Surprisingly, at the end, it comes down to one rule: the Pauli exclusive principle, which means that electrons don't like to be alike. In fact, they despise each other. But you gotta keep in mind that all the electrons are the same. Not somewhat similar, but exactly identical. Think about it like this. All the electrons are from the same factory, manufactured exactly the same way. Or the same way when you write a 3, no matter how or where you write it, it equals 3. Or maybe when you write a 3 and a negative 3, it's the exact same thing but with opposite effects. It's the same thing that happens with electrons. And when the positive and the negative 3 collide, it equals 0 or nothing. Electrons aren't allowed to be too close to each other. The universe just won't allow it. So matter is just anything that takes up space. Like a friend here. But the whale and the door, balloon, paperclip, and apple also have something else similar. They're all made up of atoms. Tiny little things made of particles. Now when I say things, I mean things because they can be anything. The atom is made of protons, electrons, and neutrons. Now, the atom has two distinctive parts. It has the nucleus and the electron cloud. The nucleus contains the proton particles and the neutron particles, while the electron cloud contains the oh, right, the electrons, my bad. Now, these atoms can be unique to their element by the number of protons. And the atom will be identical if it has the same number of protons. And if they are neutral, then they will have the same number of electrons to cancel out the protons. However, for the neutrons, it's a bit more complicated because the neutrons aren't set in stone and don't have a set number for their atoms. You see, these particles have charges. The neutron is neutral, so, surprisingly, it won't have a charge. However, the proton is positively charged, while the electron is negatively charged. The electron cloud contains all the electrons of the atom, and they go everywhere randomly. However, they stay in orbit of the nucleus because of the protons, and they are attracted to the positive charges. For the nucleus, it is a small yet very dense part of the atom. This is the home for the protons and the neutrons. However, the protons are both positively charged, so they repel each other and don't want to be next to each other. This is where the neutron comes in play. The positive charges are going to want to repel each other, so what the neutron does is it gets in between them and acts like a wall. But if they're not set in stone, what are the extra neutrons called? Well, they're called isotopes. Now, if you look at these two hydrogen atoms, One is an isotope, and the other, well, it's also an isotope, but let's not care about that. This hydrogen here is hydrogen 2 with the atomic mass of 2, while the hydrogen 1 has the atomic mass of 1. The reason it has 2 is because it has a neutron. Now, does a neutron affect the atom in any way? Simple answer, no. Now let's get back to our whale, our narwhal. The narwhal and everything else is made up of atoms, and atoms are made of protons, electrons, and neutrons. But wait a second. Are the particles, protons, neutrons, and electrons made of anything else? Well, scientists call these smaller particles that make up the bigger particles quarks. Now, although scientists don't know much about them, because we can't really study such small particles, we know that quarks make particles, and particles make atoms, and atoms make everything else, like our narwhal.